Hi class, here's problem number 3 from the uniform distribution. So here's the main highlights. When you have a uniform distribution, your picture is going to be a square or rectangle. So for instance, on the first question, when they want to see a sketch, make sure that you include technically the title, the arrows on the axis, and then technically your event only occurs from 123 from 125. I'm obtaining those values from above. Now your probability for each of the events is constant, so that's going to be your 0.5. That's this portion here. For the other parts, they're going to be asking for probabilities of the actual event. And the first part to do on any of these probability problems is you declare their variable. If there's no units, you simply say random variable. And then for the part that says less than 123.5, that's, well, technically here I provided you the sketch of the entire distribution. And that just represents this squared here. Now, this probability, technically your random variable is continuous, so writing it as less than, it will be the same as if you write it as less than or equal. So both of those will be perfectly fine. And in this case, you're just multiplying 0.25 times 0.25, which is going to give you, actually, sorry, 0.5 times 0.5, which is equal to 0.25. Now, part C, the actual event that they're talking about is just in between the values of 124.1 and then technically 125. So this rectangle happens to be a length and width of 0.5 times 0.4, so a total of 0.20. Now, the last portion, your event only occurs within, oh, I have a typo here. So this is supposed to be a 7. Your event, it's only going to occur within 123 to 125. So that's going to be these values here. And then for the event they're asking for more than 127, that's going to be, well, technically out here. So in this case, your probability happens to be 0. And it is perfectly fine for these events to write them as greater or greater than or equal. And that is because your random variable happens to be technically continuous. That's actually it for this problem.